To prove this equation, we want to begin by making two columns, labeling them statements and reasons. What's on the left side of the equal sign and what's on the right side of the equal sign will become our first statement and our last statement. My first statement is called the given. I'm going to rewrite 3x as 2x plus x. 2x will be the a and x will be the b in the sum difference property that I'm going to use next to expand. Applying the sum difference property to the sign of 2x plus x, where 2x is my a and x is my b, I get the third statement. My third statement contains the sine of 2x and the cosine of 2x. These are both double angle properties. I focused first on the sine of 2x because there is only one double angle property for the sine of 2x. So I replace the sine of 2x with 2 sine x cosine x. Next, I start thinking about what I might want to replace the cosine of 2x with. We have three options for the double angle formula of cosine of 2x. So I need to look at my final statement. Looking at my final statement, I notice that the only trig function in the final statement is sine. But something else I notice in the meantime is that there's a sine x out front. When I look at the fourth statement, I see that before and after the plus sign, I see a sine x. So if I factor a sine x out of both of these terms, it will look more like the final statement. Factoring out a sine of x from the term before and after the plus sign, I get this. Now, I'm going to get back to what I might want to replace the cosine of 2x with. Noticing that all the terms in the final statement have sine of x, I want to choose the double angle formula for cosine of 2x that contains nothing but sine. I chose to replace the cosine of 2x with 1 minus 2 sine squared of x. Continuing to look at my final statement and my sixth statement, I notice that my sixth statement has a cosine squared of x, yet my final statement has nothing but the sine of x. So I'm going to need to also replace the cosine squared of x with something that contains just sine. I'm going to use a Pythagorean identity. The Pythagorean identity that relates sine squared of x with cosine squared of x is sine squared x plus cosine squared of x equals 1. If I solve for cosine squared of x by subtracting sine squared of x from both sides, the Pythagorean identity turns into the cosine squared of x equals 1 minus sine squared of x. So I replace the cosine squared of x with 1 minus sine squared of x. I like the way this is headed because everything in my current statement contains the trig function sine of x, and my final statement also contains nothing but the sine of x. All we have left is a little bit of simplifying, so I distributed the 2 through 1 minus sine squared of x. Combining like terms, 2 plus 1 is 3, and negative 2 sine squared of x minus 2 more sine squareds of x's, we get negative 4 sine squared of x. Typically, I work backwards from the final statement at least one step. In this case, I did not. However, I did keep an eye on the final statement throughout the proof. Keeping an eye on the final statement helped me to select which properties I might want to apply so that it would make what I currently had look more like that final statement.